So you can get 4 pandas, 7 chameleons, and 10 macaws for $104, 2 pandas, 1 chameleon, 3 macaws for $13, 5 chameleons, and 1 macaw for $33. What's the price of each animal? That's what you'll find out how to figure out in the systems of equations with 3 variables. Your goal is to solve 3 linear equations using matrices. Now, what you should understand by the end of this lesson is that when you're solving a system of equations that have 3 variables, you find a value that replaces the variables that makes each one of the equations true. To graph a linear system with 3 equations, it would give you a 3D graph, but you solve them in the same way as those that have 2 variables using matrices in your calculator. If you were looking at a graph of a system of equations with 3 variables, they would look not like lines, but like planes, or like pieces of paper. And the solutions of 3 variable systems, they're shown as intersections of planes, not by lines. And remember, we're looking where they all come together at a single point. So you could have no solution where there are no points in all of the 3 planes, as in the top 3. You could have one solution, like the one to the left here at the bottom. It meets right there, is where all 3 of them meet. Or they could meet and have an infinite number of solutions because they all meet along a common line. That's what the solutions of 3 variable systems look like if you were to graph them. I'm going to show you how to solve these using matrices in your calculator. We're going to solve them exactly like we did before, only we're going to use matrix A is going to be a 3 by 3 matrix because we have 3 variables, x, y, and z. And matrix B is going to be a 3 by 1 because we have 3 equations and 3 constants. So that's the only difference, is the size of the matrices. Everything else is exactly the same. The buttons we push are the same. We get the answers the same way. It's just the size of the matrices that are different. Let's look at how to do it. Here I've used my second matrix, Edit A, to go into matrix A, and I've changed the size to 3 by 3. Now along the top, there were no x's, so I put in 0. There were 2 y's and negative 2 z's. In the second equation, there were negative 2x, 3y, 2z. And in the third equation, it was negative 1x, 1y, 3z's. I now am done with that one. I'm going to push second matrix 1, or matrix inverse, or second matrix, edit, drop down to B or push the number 2, and get ready to put in the constants. I've changed the size of my matrix B to 3 by 1. I've entered my constants, which were 16, negative 8, and negative 20. Now I have to clear my screen, push second mode or second quit, the button right next to it, push second matrix. And now you're going to be doing matrix A, the inverse of A, times matrix B. So after you've cleared your screen, you go to second matrix, enter, the inverse button, times second matrix, the number 2, or go down to B, and enter again. And I have 3 points of intersection. Again, they are in X, Y, Z order. So my point of intersection is X is -4, Y is 0, and Z is -8. So on a 3D graph, the point of intersection of those 3 lines would be -4, 0, -8. We're going to look at another one. I have X minus 3Y plus Z equals -19. The next equation has no X's, so I will be putting in 0 X's. -2Y plus 2Z equals -20. 3X minus 1Y minus 3Z equals 7. And I'm going to enter that in to matrix A. And, of course, these are my constants. My matrix A has my coefficients. I have 1, -3, 1, 0, -2, 2, 3, -1, 3. Now I'm ready to enter matrix B, which are my constants. I've gone into matrix B. My constants are -19, -20, and 7. I cleared my screen by pushing second, quit. I'm multiplying the inverse of A times B. I pressed enter, and this time my point of intersection is 7, 8, -2. So it's done the same way, only change the size of the matrices. Here's practice 1. And I know these all, by the way, I know these all say solve them by elimination. You could solve these by elimination if you wanted to do them algebraically, but it's a whole lot easier by doing them on the calculator. Practice 2. Practice 3. Practice 4. Practice 5. Practice 6. You're going to be going into IXL to do your assignment for the day. The next lesson is going to be called linear programming. We're going to be doing this on the calculator also. We're also going to be doing linear systems of inequalities. But if anybody listens to this video all the way to the end and can tell me the price of each one of those animals that I showed you at the beginning of class, it's worth a $5 bill. Have a great day.